everyone. In this quick tutorial, I want to discuss a few fabrication tricks you might want to use for wooden construction. So I want to show you how you can basically add joinery when you have a wooden construction like this. So I'm using a simple way of overlapping pieces here, but of course we don't know how these pieces hold this shape. So I'm developing a way of drilling these sorts of holes so that we can have some sort of information on these pieces. So we can think about preparing each individual piece for fabrication. And the other thing I want to show you is how can we keep some sort of identification for these pieces, right? For instance, let's say you want to build this thing in groups. How do we actually decide on where to divide this into logical groupings, and also how to identify individual pieces? So we'll be looking at some of these things. So let me walk you through what I have in mind. So the first thing is identification. So how do we identify these pieces? Well, you can actually generate a bunch of layers for groups. Let's say you want to make a group 1 or group A and group B, obviously, right? So you can just give them different colors, and maybe this part of the structure is part of group B, and maybe this part is group A. So you can just put them in different layers and give them identifiable colors, basically, right? So it's something that differentiates this geometry. Well, the other thing is then how do we go about identifying individual pieces? So let's say we are working on this group here and we want to just fabricate it with these joints. Let's say I just move them one by one. So I'll make a copy of it, and then let's say I want to organize them, lay them out flat. Well, the problem here is after a while, you will lose track of which part is what and where the joineries are, right? So we don't actually know where the hole on these pieces are. So one thing we want to keep track of is the identification of pieces. So for that, you can actually create, let's say, dots or like a tag. So the way dots work is basically you can type in dot and give it a text. So let's say if this is group A, I can name this piece as A1, and then I can give another piece A2. And if I group these with each other, then I can simply make another copy and maybe put dimensions on the laid out pieces so that I will have an idea about where the pieces in 3D and in 2D, right? Well, we also need to get some sort of information of where the joints are if we are maybe drilling holes on this. Or if you want to do it on the go, you can also think about marking them maybe so they can work like a marker. So how do we put the joiner here? Well, again, let's say we want to put a cylinder there. I can go to an orthographic view that looks at that elevation. So actually the pieces are here, so I want to find A1 and A2. So let's say we want to drill a hole at this intersection here, right? So I can simply draw a cylinder and find that center point. So let me actually turn on projection, and I'll just make like an X and put a cylinder here. Well, it's, I think, a bit wide. Let me actually turn off the grid snap and put a cylinder. And let's say this is the hole we want to punch. So I can do a Boolean difference, subtract this geometry from the wooden pieces. So now if I make a copy and place it in 2D, I will basically have that hole or the joint information marked on the piece as well. So if I want to, let's say, find for the placement of it, I can simply grab its center point and I can make a dimension and find out where that hole is in respect to the whole piece, right? So we can make drawings like this. And maybe this one has multiple holes, so we want to just mark those connections on the piece itself if you have unique pieces like this. Okay, so this might actually take a little bit of time. So what I have in mind is, like, can we actually automate some of this workflow? Well, the good news is you can actually, if you're drilling holes like this, you can have placeholder geometry. For instance, if you put boxes like this, since these have some dimensions that are similar, and then we can actually bake some other geometry inside of this and then do a Boolean subtraction. So this is what we call as a box morph method. So let me show you what it does. So I'll just show everything else. Okay, so this is my placeholder for the geometry, and these are the joints. So let me isolate them. So I'll go back to Grasshopper. And the script works something like this. So I'm just going to disable this for now and look at these dowels. So let's see where the dowel is. So this geometry is actually the cylinder that we want to subtract from the wood, right? So this is the cylinder inside. And this is a kind of a reference geometry, which is the bounding box around this. So what I'm trying to do is basically remap or translate the cylinder that is in relationship to this box to these boxes, right? So that we don't have to model them one by one. If you model, let's say, find these placeholders for where you want the joints and have a special joint condition here, you can just remap those onto those joints. And that's kind of what this does. So if you go to the target boxes, so these are my target boxes. So let me actually clear the values in there. Right click here and select all the joints minus this one. So what this does is it takes the cylinder, or what I call as the dowel, that is inside of this red box, right? So that's the dowel, and it takes the reference, and then it maps that using a method we call as box morph. So it takes the reference and the geometry that we want to map and maps it to the target geometry. So the target geometries are these joints. Now, if I bake it like this, let's actually check what's going to happen. You can see that these are not correctly aligned. So this mapping actually works according to the reference plane. So right now my reference is along the y-axis. So all of the cylinder placement follows the y-axis. Well, if you want to do it the other direction, then you might want to separate the target boxes in the orientation that you want. So let me actually go back a few steps. So these are in the correct orientation, and I have a second group of boxes that are in the opposite direction. And for those, I simply do a rotation. So if I rotate the original geometry and the reference for it by 90 degrees, this will become its source. So now we can actually do a box morph for both directions. So this will, you can see, like, it populates all of these rods. And the next step is, after you have those cylinders placed, we can actually have all of our geometry fed in, and we can do a simple solid difference. And you might want to just sequence this. So you might want to first do a solid difference in this direction, or we can actually probably do it at the same time. So if I do, for instance, merge, let's see, merge, put both of the cylinders inside one container and just do a solid difference. So I can delete this one. and bake this geometry, you can see all of those cylinders are now subtracted from my from the geometry, right? From the verticals or the horizontals of the wood. So wherever we place that, that will kind of take effect. Now, the other thing I wanted to do is, can we automate some sort of identification and unrolling of these pieces? And for that, I used Google Co-Pilot. So I started a new chat here, and I said, I have a bunch of box objects in 3D in Rhino. They have a profile of 1 to 2 inches and different lengths. Can you give me a Python code that places them on their 2-inch face on XY plane in an array? And it gave me a code, and then I asked, can I run this inside Grasshopper? So it gave me some sort of inputs, like boxes, spacing, and gave me the code, and then basically output boxes, right? So I can show you this version as well. Let's actually paste it here. So this one has 2 input parameters. Let's see, we have output boxes as output, and the input is boxes and spacing. So spacing, we can give it some sort of integer value, and for the boxes, we can give it. So this one is giving me an array, an error because we need to choose list access, but also kind of the geometry as the input. So if you right click here, go to type hints, you can do boundary representation and a list. And what that does is it simply, it's almost like unrolling all of the pieces, right? So it just lays them out on the XY coordinate system. It doesn't do a good job of understanding the orientation of the piece, but at least like it moves them to this coordinate system, to the plane. So that could be like a starting point of working with Co-Pilot to get a custom tool that can help you organize these pieces. But I actually didn't stop there. I actually went further and asked it, well, can you also give them an annotation tag and output these tags as well? I want to bake annotations as a list of numbers and bake them into reference geometry and output geometry. So this one gave me a more complex code along with the annotations, and it had some sort of error. I basically asked it to fix it and then asked it to give me the full code. So this basically, this was basically it. So we can look at that version. But then I asked it, like, can you also give me dot text in the input geometry while baking? So this one just output them with annotation. But what we wanted to do was not only annotate the unrolled pieces, but also the pieces in 3D. So we can keep track of fabrication, but also where those pieces are in the assembly, right? So that's very important. And that's basically the final version of this code. So I asked it, can you give me dot text in the input geometry while baking? So it gave me full Grasshopper Python code with input annotations. So the inputs are boxes, spacing, and bake. This basically triggers the placement of the text dots. And then we have output boxes, output tags, input tags as well. And it gives me instruction. I also asked it, can you add a linear dimension to output boxes showing their lengths? So it basically did that as well and gave me instructions. So let's actually look at this version. So it basically has the same input, so boxes, spacing, and bake, the output boxes, output tags, and input tags. So let me show you how that looks like. So I'll put that in. This one has the final version of that code. I'll just right click, enable, and here you can see it. So these are basically the annotations it put for the input geometry. So this is piece number 3, piece number 4, and we can also find it in the coordinate system. So you can see they're being unrolled here. So if I bake this, let me actually move this to the side a bit. So I'm just going to show it, delete these pieces. Move it to the side a bit. I actually didn't want the output geometry and input geometry to overlap. But I guess we can just simply move these in the y direction. So you can, if they overlap a little bit, you can simply move them in any direction you want. So we can do this, for instance, right? So both move the geometry and the annotations and hide this stuff. Well, we want to actually see the tags. Let me see. This is text dot. So if I do text dot as an output, this is the annotation. If I do a text, I guess this would work. Well, it doesn't display it actually, strangely. So I'll just keep it like this. And we can bake these, but if I bake it, it will bake them all. Anyway, let's actually hide this stuff. So let's bake them. So there you have it. So the interesting thing is it's not as tidy as I would like it to be. So it basically doesn't do a perfect job of spacing these out. But I also asked it to give some linear annotation, right? So which will kind of help knowing the length of individual pieces, knowing where to place the holes, and also keeping track of some sort of an identification. Because once you have, let's say, hundreds of these pieces, things can get out of hand very quickly, right? So if you want to be precise of how these joineries will work, you might want to just, keep track of individual pieces. So you can organize them in groups like this, keep track of the IDs and the lengths and the kind of placement for these joints, right? So for instance, now I have an idea about where this joint is going to be, so I can maybe drill that hole or mark that point for the joinery, and then look at the 3D and put this thing together like a jigsaw puzzle. So that's kind of the idea here. And these are kind of all of the pieces. So I can go back and forth with Copilot, try to fix this, try to space them out a bit more and organize it, but I'll leave it up to you. The other thing we can try is, let's say we have another type of joinery. Let's say we have lap joints. So I want to also see if that would work. So let me go back to my input. I'm just going to disable all of this. This was my original geometry. So I'll just make a copy here and show you. This can also work with other types of joints. So I'm just going to select the dots, delete them. Let's say we have some sort of overlap between these geometries. So maybe this is like half an inch inside of this. This one is half an inch inside of this one, right? So they can maybe fit in an interesting way. Maybe these go a little bit in as well. So something like this. So what I wanted to do was ask Copilot to automatically Boolean these. I mean, find them inside Rhino and see if it can do Boolean. So what we want to achieve here is some sort of, let me show you, like if I isolate two pieces, essentially we want one of them to Boolean the other one, right? So we want to do like a Boolean difference from this geometry, but we want to keep this as well. So we don't want to delete the input. So we want to do Boolean difference. So now this would, let me see if to take effect. Okay. So that's kind of the lap joint, right? So we just like went inside of this. So I wanted to check if Copilot can automate this type of construction as well. So let's see. So what I want to ask it next is, can you give me a new code that can look for intersecting boxes and do a Boolean difference between them. I want to create half lap joints. Let's see what it will do. So it can also give me a code. So it has boxes as input, and then we just bake it so that we just get the output. So let's try running this. And if we have issues, we can always go back and try another type of approach, right? So I'm just going to copy paste it here. We need a bake parameter, which will be a Boolean toggle. And this will be boxes. So again, this will be a list of geometries. It could be boundary representation. And we have output boxes. And let's see where the input boxes are. So boxes are the input. Okay, perfect. So I'm going to just create a geometry container, set multiple geometries, choose all of this. So I only have a few overlapping joints here, right? Not in the rest. So just curious how this is going to resolve. So it runs. So if I do true, false, let's do it true again. Well, it's giving me output boxes, so let's bake them. Well, it didn't actually do the Boolean here. Let's see how that works. So this assumes boxes are already aligned and overlapping in a way that makes them half-lap joints meaningful. You can extend this to tag joints, visualize for more precision. You can slice the intersection volume and subtract only half of it geometrically. Yes, let's implement it for more precision. Can you look for all the intersections, all the volumetric intersections between boxes and subtract them from one of the boxes? Because two of them will give the intersection, so we don't want both of them to be subtracted. We just want it to be subtracted from one of them. So let's see, it detects all intersecting box pairs, computes the exact intersection volume, subtract full intersection from one box. So let's see if it does what it promises to do. So again, I'm just going to run it. We don't get any errors. Right click, bake. Well, it seems like it actually worked. Perfect. So you can see these are now Boolean subtracted, right? So I just made intersecting joints here. Oh, it also made it here. Made them here at the bottom. This is very nice. So now you can actually create kind of these divided pieces automatically using these scripts. And the other thing is you can create this type of workflows, additional scripts where you can annotate them, unroll them so that you can organize them in pieces. But make sure that you create groups, create logical annotation tags so you don't lose track of the pieces. And hopefully these tools will help you put all of this together. Okay, and if you have any questions, you can just write in the comments below, and maybe we can do another tutorial on this. All right, thanks for watching.